I'm going to walk through building a basic attractor definition to create a kind of surface pattern with respect to a point that can change position within a given area. So let me turn on the output here, and let me turn off the input surface here and hide this. So what we see here in this definition is the result of an attraction or repulsion type definition where you have a point, and the point is influencing the grid which is present on a surface, and the grid is comprised of subdivisions, and at each point in that subdivisioned surface, circle is placed. And so let me turn on this. So these are the points, as you can see with the little green X's, and at each point is a circle, and the circle is filled in currently with a swatch, and I just disabled it. So when you move the point around, what you see is a change in the overall set of circles that make up the points on the surface. So we'll walk through this definition and get to this result. So I'm going to go ahead and start over by making a new definition in Grasshopper here, and go to my top view here, and the first thing we want to do is create a surface component. So I'm going to go ahead and define my surface in this file here, and I can do it with a rectangle or create a surface from a rectangle. So I can enter a rectangle in, so I'll just make it about that big, and I'll make a planar surface on that. And so if I go and change it to ghosted, I can see my surface. I have a curve here too. I can delete that curve, I don't need it. And then I'm going to go ahead and make a point. And so my point is the thing I'm going to move around. And so first I need to reference my surface. So I'll set one surface, and then I can hide this. And so now I brought that into Grasshopper here. And so next I need to take the surface, and I'm going to divide it into UV coordinates. So divide surface is the component I want. And this is just a nice way to take a surface of really any shape and size and divide it into a different coordinate system with respect to the surface itself. So U and V, you can think about them as like an X and Y coordinate, but with respect to a surface instead of the world coordinates. So by default, this thing comes with 10 and 10 divisions. So let's go ahead and put some sliders in so we can play with that. And you can see if I straighten this up a little bit, if I move these, I'll get more or less divisions in each direction. So for now, I'll leave it at 10 and 10. And this is basically going to output a grid. And so it's similar to the rectangle grid component in that I get a tree structure, and this has 11 branches, each with 11 values in it currently because of my sliders here. If I bring these down, I'll have fewer branches and fewer elements per branch. And so to visualize that, I can go ahead and pull up or go to my params util param viewer, and I can hook that up here, and I can see my data tree. So if I zoom into the data tree, I can see I have one main branch and 1, 2, 3, 4, 5, 6 secondary branches here, each with 6 elements, n equals 6, so 6 elements. So that's because I have these grid components set here where I'm dividing into 1, 2, 3, 4, 5 divisions, but there's 6 points in each direction. And so another way to visualize that would be to use the point list component and just hook up the points to that, and I get a little number here, but I want to go ahead and see the numbers so I can scale them up a little bit. So what we have going on here is this is displaying the output of my my divisions here as the tree structure. So I have in this column, this is 1 branch, 2, 3, 4, 5, 6, and each one has 6 elements in the branch. So that's what these numbers mean. Now if I were to flatten this tree structure and visualize the output with numbers, with the point numbers, I could see now that my entire list, which was a tree, has now been flattened down to a single list with 36 elements, and they're organized from the bottom left here to the top right. So it goes 0 through 5 and then 6 through 11 and so on. We're not going to use that right now, so I'm going to delete it, and we can leave that hooked up so we can just see the numbers, make them smaller for now. Okay, so now the next thing we want to do is to get this sort of point influencing the geometry of different points on my surface behavior. We need to calculate the distance between an attractor point, which I'll call this one, and every single point on my surface. So the way we do that is I'm going to bring in my point, my attractor point, and reference it. So set 1 point, this one, okay, and I'm going to go ahead and just hide that, but I can still have control over where it is here in Rhino and manually move it around. I could also define this point purely in Grasshopper, just as I could define the surface in Grasshopper too, instead of bringing it in like this. But in this case, I'm defining it here. And so we'll go ahead and just call this my association point. So it could be, I could call it my attractor point too. I'll just call it association point. And I'm going to pull out the points from this list too to just a single component here so I can see this if I need to move it. I'm going to hide those for the moment. Okay, so what we want to do is calculate the distance between this point, these points, and this point. So there's a command component called distance, and it calculates the distance between 2 inputs, 2 points. So I'm going to give it my association point and my list of grid points. So what I get is the distances. So if I were to, let's say I put a line component in here and I draw a line between this point and all the other points, I'll get something like this. So this is what we're doing. We're calculating these lengths of each line. So I can easily see that the distance between this point and this point would be smaller than, say, the corner point in my association point. So we can use that length now to influence the patterning of the grid. And so what we want to do is create a circle, and that circle is going to be positioned at every single point, like so. And if I just hook up the radius, we'll see what happens. I get kind of a big mess because I need to, the radius is being set by the distance between each point and my association point. And the problem is the scale. So this is really small. The closer the points are, the smaller the circle will be, but it's still too big to make a nice pattern. So I need to remap these numbers. And so there's a component that will help with that called remap numbers. So this component takes as an input the the value I want to remap, and my source domain and a target domain. So the source domain is 0 to 1 and the target is 0 to 1 to start, but I actually need to create a different domain. So what I need to do is take my distance values, and I'm going to plug those into the value because that's what I want to remap, and then I need to calculate the bounds of my my numbers. So my lengths are kind of all over, and if I look at it with a param, or with a panel, sorry, look at the values themselves, I can see they're sort of all over the place. They're going to range from really small for the points that are closer to really large for the points that are farther away. And so what we need to do is get the minimum and maximum of that list. And so if I bring that in here to this component, I can get a numerical domain of the minimum and maximum. And so to get that, what I need to do is flatten the input, which will remove the tree structure. And so now I just have a list coming in, and at the output I'll see a numerical domain now from 3 to 55.86. So that's my start domain, that's my current mapping domain, and now I need to give it a target domain that I can control, because I'm going to use this, the output of this remapped numbers, as the input to my radius. So if I hook that up now, we can start to see a little bit of a difference. But we need to be able to scale the values coming out of here. So I'm going to construct a domain, which again is 0 to 1 right now, and coming out of this component is 0 to 1. And so I can set some sliders for the input. So let's go ahead and just say number slider. So kind of set them to like 0 to 1 for the moment, and see if we get anything. We need to scale this one up. Let's say we go up to like 10 and start bringing it up. So you can see immediately I get a result here. So what's going on is I'm scaling the number range I'm mapping to. So I probably don't want to start at 0. That would mean the closest values would be extremely small. So if I bring this up a little bit, I can start to see it rescale them a bit. So kind of bring this up, maybe bring this up so I can see it. So I'm going to hide my points and hide my original surface. And so now we can see if I start moving this point around, it's going to change the scale of the circles. So if I move it close to this corner one, it's going to make that one the smallest, and so on. So you can see I can quickly get a more complex pattern just by moving the point and adjusting my domain here. So you get overlapping here too, because there's not really anything to limit the range other than these two sliders. So you can get some interesting results with overlapping too, but I'm kind of keeping it simple in this one and just showing how to use the distance component to create a grid that impacts, or create a grid that impacts the overall pattern by using an association point. So after this, we could put in a surface and just kind of quickly give the points a little bit of color with the custom preview. So hook that up and swatch, color swatch. So with this, I can kind of change the color of my output here. Do something interesting, and I could bake this like so, and bring it over here. Oh, I moved the point, so maybe I want to select everything but the point, and try that again. Oops, I think I deleted it. Bake. Select everything. I don't want the point. Move this over. So there's my result, and if I look at it rendered, we can see that there. Let's go to ghosted. There we go. So we can see our surfaces right here. So you can get more. This can get more elaborate. You can have multiple points. Let's see. Let me create multiple points here. Boom, boom. Let's see if that works. Let's go back here and let's set our multiple points. And so with multiple points, it's going to influence it from different directions. So this grid isn't really that dense, and so the multiple points won't make as much of a difference. But once you start adding more, it's going to change the color again. Once you start adding more grid units and make the surface larger, and also start tweaking more of the minimum and maximum values, you get some pretty interesting results. You can also change this component out, the circle component, with a polygon object. So if I put in a polygon object instead, and let's see, let's shift this up to here, shift the radius up to here, then shift this down to here. So essentially replace the circle with a polygon. And gonna change the color once again. Okay. Then you can see you get different results. I'm gonna delete these points and just set a single point again. Set one point. So I can kind of go like that. And the polygon object also has a number of sides available. So I can hook in a slider and change the number of sides. So something like that. So that's how you use the distance component to create variation in a grid.